So, like day before yesterday, we completed till this, like the what happens for the electric field for the hemispherical cell and all these kind of different cases, hollow hemispherical cell, cavity, and all these kind of things, isn't it? Now today, we are going to discuss. Oh, sorry, one of the most important topic, which is usually there, and we call it as electric dipole, isn't it? Now, there are many things to consider about electric dipole, but what we are going to look for the electric dipole is its basic clear understanding. Is that clear or not? ठीक है? So, it means the point is that dipoles. 1 minute. Yeah. So for dipoles, we can consider like if you look into different books, they tell that plus q and minus q when they are kept together, we call it as dipole or something like that, isn't it? So with that kind of understanding, we can have a very good clear position that oh, this is dipole or this is something meant by it or something like that. But here we will have a much more great description of it. Like I have concluded some of the important things about dipole, and let us see what are those. Is that clear or not? Okay. So let us start it. So first thing, what is electric dipole? So basically, it is a combination of two equal and opposite charges. Is that clear? It's a combination of two equal and opposite charges placed at a small distance with respect to each other. Are you able to get me or not? Then this system is called as a dipole system. When two equal and opposite charges, which will be placed equal and opposite, like which will be placed at a small distance with respect to each other, we call it as electric dipole. Are you able to get me or not? So look over here. Almost close to each other. Perfect. Like let's suppose one is positive and another one is negative charge. Okay. So there are two charges over here. You can see that one is positive and another one is negative. Okay. So the condition is this is plus q and this is minus q. So you look over here, their magnitude is same, right or not? And but they are equal and opposite of each other and they are kept at some distance away, which we call it as length L. Are you able to get me or not? Okay. Now the point is, next point, the condition is that what is this electric dipole means? So we will define it. Basically, it is a vector quantity and its direction is always from the negative charge towards the positive charge. Yeah, means not a dipole. I'll tell you. See, Acha, if you look into the condition that electric field is from positive charge towards the negative charge or not. That's right, isn't it? Now, what is the meaning of that? That the plus charge will be getting attracted towards the negative charge, isn't it? But here, actually, a dipole is that configuration where this plus charge and minus charge are actually fixed. Means they are kind of stationary. Are you able to get me or not? Yeah, they are at rest, although they have the attractive force between them. Are you able to get me? So you can see, like, see, in reality, it is not possible to take out the charge plus q and minus q and put it like this way. But we can see some configuration like this. Like, if we see the HCl molecule, got it or not? So H is H plus, Cl is Cl minus. H is too much highly electropositive, right or not? And Cl minus is too much highly electronegative, isn't it? So what happens? Basically, this plus charge and minus charge, they are trying to attract very strongly towards each other. But is the atoms are actually merging? No, they are just creating some kind of shape like this way, isn't it? Yeah. So that means what? Something is separating them, means something which is keep something which is there, which is keep the which are keeping these atoms separate or not. Are you able to get me? So that thing, that property of saying in physics was told that we can call it as a moment which we basically name as a dipole moment. Like the moment exists from negative charge towards the positive charge, which prevents the attraction and they keeps it ultimately some kind of a stable. They keeps this plus q and minus q in some kind of a stable configuration. If it is an atom kind of thing, is that clear or not? From the negative charge towards the positive charge, or you can say the directly opposite of electric field, such as the system remains stationary. Are you able to get me? They must be in same magnitude, but we'll see later on whether they are in same magnitude or not, or they are differentiated. There can be differences, isn't it? So next point is, so this is what they said, that electric dipole, it is measured in terms of dipole moment. Got it? And the dipole moment is given by formula. This is represented as P. It is given by formula Q dot length L, where length L is the gap between the charges, plus Q and minus Q charges. It's not a dot product, it's just written as a multiplication form. Is that clear? And the SI unit of this dipole moment, many people does not say the SI unit. Actually, the SI unit of dipole moment is Davies. Is that clear? Are you able to get me? So this was the consideration of dipoles. Is that clear? So basically what it is nothing but it is an moment which is existing between the dipole system, means dipole is a configuration basically. Dipole is a configuration of plus and minus q charge, and there is a particular measurement of dipole with the method of dipole moment which exists actually perpendicular in the opposite direction of electric field. Are you able to get me? Is that clear? So let's take an example. Let's solve some question to understand what will be the dipole moment of those such configuration. So look over here. Let's suppose I told you that I placed some charges. Here it is plus 3q. Here it is minus 7q. And here it is plus 4q. Got it? And the distance between these particles, these charges, is a on. Then the question arises that what is the dipole moment, net dipole moment? What will be the net dipole moment? So there is a process of doing these questions. Okay, Srishti, look over here. How you are going? Means you need to see. The condition is that there should be equal and opposite charges, isn't it? So if it is here plus 3q in the opposite direction, I can separate this minus 7q in two terms, minus 3q and minus 4q, isn't it? So then I got two dipole moment vectors or not? So look over here, I have A. So one is, this is my dipole moment vector from minus q to plus q, which I call it as P vector, P1 vector, which is equal to how much? Simple, 4q into length A. Is that clear or not? Another dipole moment vector will exist along this side, which will be P2, and that will be equal to how much? What is actually down? So that is equal to how much? P2 is equal to minus 3q to plus 3q. It will be then 3q into length A, isn't it? So I got two dipole moment vectors. So therefore I can find the resultant dipole moment vector or not. So P resultant. Now look over here. If this is 3, this is 4. Got it? So that means this is 3 and this is 4. So this angle will be 37 degree or not. So P resultant is how much? Simple. Root under 3qa square plus 4qa square plus twice 3qa 4qa, got it, into cos 37. So can you just solve it? Is that clear? Basically people write qa as p and then they just solve it using random method. So basically if I just write qa as p, then this is 3 and this is 4 or not. So resultant will be simple 5qa. Got it or not? In simple terms. You can use that also trick or this also method. Is that clear? Okay, can we move to next question? Okay, now look over here. The question is, let's suppose I have a straight linear rod. Okay, and it's divided into two parts. This is length L. This is also length L. Got it? And in this rod, there is a configuration that this half part has plus Q charge. And this half part has minus Q charge. Then question is, find the dipole moment of the rod. Do it. Find the dipole moment of the rod. Is it? Okay, so I'll tell you one thing. There is a way to do this. Is it a continuous body or not? Yes. So wait, do not take tension. So remember that for calculating, there is a trick for this because we do not require such a kind of integration and all. For calculating the dipole moment of continuous bodies, use the method of selecting the charges at center. What you do? For continuous body, wherever the charge is, just select the charge to be at center. Are you able to get me or not? So if it is a rod, then what I will see? If it is a perfect rod, then see that. If it is a perfect rod, then what I will say? That this plus q, okay, that our plus q is located over here, isn't it? And yeah, it will behave like a point charge and minus q over here. But if they are in the center of this half rod, that means this distance is how much? L by 2, and this distance will be how much? L by 2 only. Is that clear? So net distance between the two charges is how much? L. So therefore dipole moment is q into length. Is that clear? Are you able to get me? So for continuous body, just consider the charges to be at center. Is that clear? Let's suppose let us take another example, one more example. Okay. So let's suppose if I have a ring, got it? And for this ring, I divide this ring into two parts. Got it? And let's suppose the radius of the ring is r, and this has plus charge. This side has plus q, and this side has minus q. Then find the dipole moment of the ring. Find the dipole moment of the ring. बताओ. Tell me fast. No, no. Why too loud? Then you think of another case. There is a disk. Divide the disk in two parts. Okay. And then another one side is plus. Another side is minus. Yes, and the radius of the ring is r. The disk is r, also r. Question is find the dipole moment of the disk. Easy. Just do it fast. Simple. Look over here. You see the ring portion. Basically, the center of ring. See, the plus charge is spread on the semicircular part or not. This is my origin. And this is my origin 0, comma 0. Then the center, like if I just talk about the center of the semicircular ring, the center exists somewhere over here, isn't it? Which is exactly at the distance. Remember that it is exactly at the distance 2r by pi. Didn't you did center of mass? So there it they teach us that the center of mass means what? Center of the particular system or not. So basically for semicircular ring, the center exists at 2r by pi. Are you able to get me? So plus q will exist over here. Similarly, minus q will exist over here, isn't it? That will be also at 2r by pi. So therefore, dipole moment will become how much? P vector will be q into 4r by pi, because 4r by pi is my distance between the two charges. Is that clear? Next question, try it. Dipole moment for, so look over here. Then once again, for the disk, for my particular disk, where does my particular uh, where does my center exist? So once again, it will behave like a two semicircular disk or not? Simple है ना? यहाँ पे क्या होगा? प्लस क्यू, और यहाँ पे क्या होगा? माइनस क्यू. सॉरी, यहाँ पे प्लस क्यू और यहाँ पे माइनस क्यू. Is that clear? Remember that this distance from the center, basically it is how much? It is basically 4r by 3 pi in that semicircular disk. Is that clear? 3 pi. Center of mass, just like center of mass, you have to remember it. Okay? Is that clear? So therefore, dipole moment will be what? Q into 8r by 3 pi. Is that clear? Which is the dipole distance between. Is that clear? So this was the different cases of dipole, and we did so many questions on this. Now the question arises that if it is a charged configuration, then it will have its own electric field and own potential or not. So look over here. First thing is, like, if you consider any two kind of charge, let's suppose this is plus charge and this is my minus charge. Okay. And if they are placed somewhere, see. So look over here. This is my plus q and this is my minus q. So then I have three different kinds of points or not. One along the axis, one perpendicular to it, and one random point or not, isn't it? The point is I want to find the electric field and potential at all these cases. Is that clear or not? So now look over here. Let's suppose if the distance, see what we take into consideration that for this particular case, we consider that the amount of length between these two charges is actually how much? 2L. How much is that? Yeah. Why? Because when we are doing calculation, 2L will provide us a great benefit to do the calculation in much more easy way. Is that clear? है ना, क्योंकि अगर हम L लेते तो हमें L/2 मानना पड़ता है इक्वेटोरियल के लिए. Is that clear or not? Okay. So look over here. The first case we will discuss right now, and that is E and B means electric field and potential at the axial point. Electric field and potential we were discussing. So first case is my axial point. Is that clear or not? Axial point means, look over here. The axial point means the point which lies along the axis. Is that clear or not? Are you able to get me? So let's suppose if I select this point P along the axis and I want to find the electric field over here. So see that. Now you try to understand first important thing. Actually, what is the meaning of this axial point and what is the meaning of this tool? मैं बता रहा हूँ समझना जरा कि मतलब इस डाइपोल इतने नजदीक है मतलब ऐसे समझो कि दिस 12 इज इन माइक्रोमीटर्स इज इन विच मीटर्स and then the point which is from these charges is also is almost in millimeters. So millimeter is in 10 to the power of minus 3 or what, and micrometer is in 10 to the power of minus, isn't it? So look over here, how much bigger these axial points are. Axial points are too much far away as compared to the distance between the charges or not. So you can see like in reality what is actually there, that this is my plus q and this is my minus q. Got it or not? And this is my axial point. So when I consider the axial point, almost I'll have to take, if I take from this plus 2, so plus q and minus q, almost I'll take from the center or not. Like if I just select that, where is this axial point from this dipole configuration, almost will be at the average distance bit from them or not, which is almost at the center, isn't it? So this is why we are going to include that. We are going to mark, let's suppose that this, although this axial point was at some distance away from minus q, but we'll not consider from there. The reason for that is that this distance 12 is very very small, so I need to consider it from the average distance, which we call it as the center. Is that clear? So let's suppose from the center the point P axial point lies at a distance r. Are you able to get me? So axial point means the point at a distance r from the center of dipole. Is that clear? So if it is at from the it is at r distance away from the center of dipole. So from plus q it will be L plus R, isn't it? And minus q it will be R minus L. Are you able to get me or not? Now look over here. The electric field direction due to plus q and minus q will be due to plus q the electric field will be in this direction. Due to minus q the electric field will be in this direction, isn't it? This is the electric field due to plus q and this is my electric field due to minus q. Are you able to get me? So therefore net electric field is what? 0. Is this point P is at same distance from plus q and minus q? So then how come it is 0? Although I am measuring it from center, but from there is a gap, little bit gap or not. So definitely some electric field exists over there. So E net at point P, it will be, which one is stronger? E due to minus q is stronger, isn't it? And E due to plus q is weaker. Are you able to get me? So let's suppose if I write the electric field, what I will write? KQ by R minus L whole square minus KQ by R plus L whole square, isn't it? So now look over here, this electric field will be what? KQ common. I can take R plus L whole square, R minus L whole square, and then you put it in numerator, R plus L whole square. minus R minus L whole square, isn't it? So what I get over here? Then in it is simply KQ, and this is what? R A plus B into A minus B, isn't it? So what I will get? R square minus L square का whole square, isn't it? And in numerator, this will be what? R means the square terms will get cancelled. What will be left? I'll be left with 4RL or not, because here it will be plus 2RL which will be left, and here also plus 2RL, isn't it? The square terms will get cancelled because of this negative sign, isn't it? So what I will get? 4RL. Are you able to get me? So now look over here. Now you see that one thing is there. See, this R is too much bigger than L or not. So this implies what? Wherever I'll get L square, it will be almost similar to 0 because it is very less than R, isn't it? Means, yeah. Is that clear or not? So then what I will get? E net is equal to, this implies E net is equal to KQ into 4RL divided by R to the power of 4. So R and R will get cancelled, and I will directly write it. Okay, 4L by R cube. Are you able to get me or not? So this is my original equation, and this is the equation when R is too much greater than A. Are you able to get me or not? Now look over here. You try to see. If I look for the dipole moment exists from negative charge towards the positive charge, isn't it? Dipole moment is, look over here, what we define. It is from negative charge towards the positive charge, isn't it? So see here, although the electric field, net electric field is towards the charge only, but the dipole moment will still exist along this direction. Is that clear? In the same direction. Are you able to get me? So look over here. This, if I write in terms of dipole moment, what is my dipole moment over here? It is Q into twice L. So if I write in terms of dipole moment, the net electric field, what it will become? This implies that E net vector in terms of dipole moment is what? Twice Kp vector divided by R cube, for R too much greater than length. Is that clear or not? Yeah. Are you able to get me? Now find the potential at point P. Try by yourself. Should I do? So look over here. Potential at point P will be what? Potential at point P will be potential due to plus Q charge plus potential due to minus Q charge, because potential is a scalar quantity, isn't it? So then what I'll get? Potential at point P is potential due to plus Q. It will be KQ by R plus L, isn't it? Are you able to get me? And due to minus Q, it will be minus KQ by R minus L, isn't it? So what I will get? Potential at point P will be KQ common 1 by R plus L minus 1 by r minus l, isn't it? So potential will be kq. Once again, it will be r square minus l square, isn't it? And if you put it in numerator, r minus l, minus of r minus l or not. So minus twice l I'm getting. Is that clear? So potential at point P is what? Minus kq into twice l and divided by r square minus l square. This is my original equation, isn't it? So that means if r is too much greater than a, got it? Then it will be potential at point P will be what? Minus kp vector divided by r square. So that's your r is too much greater than l. Okay, I'm taking l. Is that clear? Now here it is minus, but here when I will consider, it will become positive or not. So let's suppose if this point P, remember, if P is towards positive charge, then only the potential is positive. Remember that. Electric field will be still same, okay? So then only the potential is positive because electric field is a vector quantity and potential is a scalar quantity. So that's why positive and negative values are interchangeable. Are you able to get me? So this is my electric field and potential for a dipole, which is for the axial point. Which kind of a point I'm talking about? Axial point है कि नहीं? बातें समझ में आ रही हैं? अब मान लो अगर चार्जेस दिए गए हैं, so let's suppose then what will happen? This is my, if this is my plus q and this is my minus q, got it? And I want to, like, the point is that distance gap between them is once again how much? Twice l. Is that clear? Are you able to get me? So now the point is, first we calculated for axial point. We'll go for the, will like for the general point will go in the end. So next point of calculation will be my equatorial point or not. Equatorial point means the line which is perpendicular to my plane of the dipole. Is that clear? So let's suppose this length is how much? R. Are you able to get me? So look over here. For the plus q, the electric field will be in which direction? Repelling. It will be in this direction. But for minus q, attracting or not? For minus q, yeah. So for minus q, it is along this direction, and for plus q, it is along this direction. Is that clear or not? So that's my electric field. This is my also my electric field, isn't it? Now look over here. If this is R, this is 2L, this length will be how much? L, and this length will be L. So this is how much? Root under R square plus L square. And this is also same. 1 minute. Root under R square plus L square. Are you able to get me? So now look over here. If I just consider this as angle theta and this as angle also how much theta, because two sides are equal to each other, isn't it? And then if I just consider this as horizontal level, then look over here. The E component along the vertical will cancel each other or not. And if this angle is theta, this angle is also how much theta, this angle is also how much theta due to diametrically opposite point. So net electric field is nothing but E cos theta. Are you able to get me? So electric field at any point P, which is basically equatorial, that means as the net electric field how much? Sorry, E cos twice E cos theta. Is that clear? Are you able to get me perfectly? So now look, if it is twice e cos theta, then it is what? Twice e, which is e is how much? Like if you find the e net, then it will be e due to 1 and 1. So it is how much? K Q by R square plus L square to the power of sorry, 1 minute, I forgot. E over there, this implies that twice e cos theta is how much? Then twice kq divided by square root of r square plus l square का whole square. That's my electric field. Yeah, so this is my electric field or not? But there is a cos theta term also. So cos theta is what? Base by hypotenuse. So L by L square. So then we got our. So then it will be twice kql divided by r square plus l square to the power of 3 by. So now that means our this is our net for this is E net for our equatorial point, isn't it? Now look over here. If we know that R will be too much bigger than L, isn't it? So this implies once again L square is negligible, isn't it? So therefore, E equation E net in terms of charge it is twice KQL by RQ. But in terms of dipole moment it is Kp vector divided by RQ. Are you able to get me or not? Right. So this implies this is E net for equatorial point, isn't it? So what you got to know that when I am going away from the axial point towards the equatorial point, my value of electric field is basically decreasing. It's not increasing. It's basically what? Decreasing. And you can write that relation that E equatorial, like if I write E axial, so E axial is basically twice times of E equatorial. Is that clear? Now look over here. If I measure the potential, since the distance is same, both of the distance is same, isn't it? So for plus q, the potential will be kq by r, kq by this root hypotenuse, and for minus q, it will be also minus kq by this hypotenuse or not. So net potential at the equatorial point, remember that potential at equatorial point is not maximum or something. It is basically equal to how much? Zero. Are you able to get me? Is that clear? So, the question arises that if I have dipole and all, okay, 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 let us just delete this. Let us not consider the charges. Now, let's suppose if on a line there is a dipole, okay, so it will be measured with respect to dipole moment vector, isn't it? I'm considering towards this side minus q and this side plus q. So if I consider any random point in the space where I want to find my dipole moment, is that clear or not? So that if I just consider, let's suppose, yeah. So let's suppose this is located at some distance r. Okay. So then, in terms of dipole moment vector, this r will be very big or not? So I'm not representing with respect to charge. I'm just representing as p vector. Are you able to get me? And then this r will be at this point will be at some angle theta with respect to p vector. So p will have coordinate what? R comma theta. Is that clear? Now over here, 1 minute, let me write it in a perfect way. Point P, sorry, let it A, which is coordinate r comma theta. And I want to measure the electric field over here. Now the question arises that if you are going to measure, it's very hard to follow this kind of methods and write the equation because they are not at same point. So what do we do is we actually do one trick thing. We resolve this dipole moment vector. Got it? So look over here. Along the line, I will have p cos theta. Along perpendicular to the line, I will have p vector p sin theta. And you know that if you look into the net electric field, there are two kinds of electric field. One, for the dipole moment is there in the same direction of a dipole moment, and another, look over here, if here it is, if I just consider dipole moment vector over here, then it is towards this side or not? And here the electric field is opposite of it, isn't it? So I should write it as minus kp vector by r cube. Are you able to get me? So for any point for any dipole moment, there are two different kinds of electric field, isn't it? So let's suppose the net electric field which came over here is this. This is my E net due to the net dipole moment. Is that clear? So then this E will make some angle with the axial line of means this point or not. So let's suppose this is making some angle alpha over here. So see, there are two things. Theta is the angle of consideration of desired point with respect to dipole moment vector. Is that clear? While alpha is the angle between dipole moment vector sorry, alpha is the angle between the, you can say, the line angle between the line of consideration and resultant electric field. I'm writing. Is that clear? So basically this is my line of consideration or not. So here E is working at E net is present at some angle alpha. So I'll measure in terms of alpha because this angle, it is not sure that if this is theta then this can be also theta. Are you able to get me? It can be anything, isn't it? So look over here, this electric field will have once again two components, E cos alpha and E sin. Is that clear? Are you able to get me? So look over here, if I want to find the electric field due to P cos theta, see there are two dipole moment vector quantities, isn't it? So E due to P cos theta will be will be along the axial line or not, which is E cos alpha, isn't it? So I'm using the trick. So if it is P cos theta, it is measuring in terms of E cos alpha. So it can be written in terms of what? Like this is an axial line. So look over here. If it is axial line, I can write it as what? Twice Kp cos theta divided by R cube, isn't it? For axial, look over there. The electric field due to axial is how much? 2Kp vector by R cube. And this is my electric field. We know that this is E cos alpha. This net electric field is how much? E cos alpha. So that E cos alpha will be what? Whatever is my dipole moment towards that side. Are you able to get me? So this is basically equal to E cos alpha, not E. Are you able to get me? Yeah. Similarly, I can write see p sine theta, when my dipole moment is equally and opposite, when it is a equatorial point, isn't it? So e due to p sine theta will be just simple kp sine theta by r cube, isn't it? And that is simply what? E sine alpha. Are you able to get me? So net electric field is what? If I want to find innate, simply look over here. Innate is what? It should be root over EP sine theta, like a square, plus EP cos theta square or not? Simply. So what is innate? Therefore we get our innate. If we take the square, what I am going to get? It is going to be Kp will come outside, isn't it? So what I'll get? Kp by r cube, and then root over, in one it is sine theta, so it will be sine theta plus this is 2 square, so 4 cos square theta, isn't it? Now I can write this as what? Cos square theta plus 3 cos square theta, isn't it? So what it will become? It will become Kp vector divided by r cube and root over 1 plus 3 cos square theta. That's my net electric field equation. Is that clear? So this is my net electric field at the general point. Are you able to get me? It is what? Kp vector by r cube 1 plus 3 cos square theta. Is that clear? So look over, it is varying with respect to theta or not. So that implies if theta is 0, that implies innate is maximum. Are you able to get me? And if theta is 90, yeah, innate is minimum. Many people see cos theta basically is cos theta is minimum at 180 degree, but cos square theta is minimum at 90 degree. Are you able to get me or not? Is that clear? So maximum value Emax is axial, which is twice Kp vector by r cube. Minimum is simple Kp vector by r cube. So minimum electric field exists at equatorial point, while maximum electric field exists at axial point. Is that clear? Now look over here. So I got this relation. You know, so I got my this electric field, isn't it? But there should be some relation between alpha and theta also or not. So look over here. I can just write E sin alpha by E cos alpha. And that is exactly equal to Kp vector sin theta by r cube by twice Kp vector cos theta by r cube. Is that clear? So you got a relation between alpha and theta, that tan alpha is basically nothing but tan theta by 2. Is that clear? So this is also one of the most important relations which we utilize it usually to do the calculations. Is that clear or not? Yeah. This is our electric field calculation at the general point. But what happens for the potential? Potential at general point. So simple potential at point P. First thing, it will be potential due to our one dipole moment cos theta, and then potential due to P sin theta. These two will be only mine, isn't it? So look over here. At the axial point, the dipole moment exists, but at the equatorial point, the dipole moment is zero or not. So yeah, it will be For axial point, what's my dipole moment equation? Minus kp vector by plus kp vector by r cube, r square, isn't it? So it will be what? kp cos theta by r square. And sin theta की वजह से तो जीरो हो जाएगा है ना? So therefore, any kind of potential that is given as uh, kp cos theta by r square. But this is something. This is looking like a some kind of a dot product or not. So we write it like kp vector dot r vector divided by r cube into write in the particular dipole moment in terms of dot product. Are you able to get me? There is a reason for it why we consider the dot product with a particular understanding for it. Is that clear? Let us see how. What's that understanding? See, I have four different kinds of quadrants, isn't it? And our dipole is placed over here. This is my p vector. Are you able to get me? Now look over here. If I try to find, let's suppose if I select any general point on the first quadrant. So p vector and r vector will make acute angles or not. So here my potential is positive. Is that clear? Let's suppose if I select any general point in the second quadrant, then p vector and r vector makes how much angle? Obtuse angle. So potential is basically negative. Are you able to get me? Similarly, also over here, the potential and the dipole moment is sorry, r vector and the dipole moment is once again making how much angles? Obtuse angles. So potential is negative. But when I consider over here, once again it is an acute angle. So potential is positive. Are you able to get me? Is that clear? Are you able to get me? So this is our condition. This is how we are going to consider. One is positive, another one is positive, another one is negative, another one is negative. Is that clear? Chalo. So these are the these are the different consideration of our dipole moment for general point and all these kind of cases. So let us start doing some questions and then we'll move ahead. ठीक है? So बोल रहा है कि let's suppose I have a square, okay, and I placed four dipoles. Okay, 1 minute, sorry. Yeah. Then I have down one like this configuration. Got it? Means it's like opposite. Okay, means here it is one thing, it is not circular. Got it or not? And the length of the square is A. Is that clear? So question is find E and V means electric field and potential at the center of a square. Do it fast. Do it fast, do it fast. You have last 2 minutes, okay? Okay. Are you trying it? How to solve it? Can you tell me? See, whenever you get these kind of question, these are different dipoles, arrows or not. What they are saying to you? They are saying nothing. Just take the. They are saying you one particular thing that we are not given casually. We are for some use, and that use is first draw the diagonals. Got it? And then this dipole moment means what? The dipole moment is going downward. So can I take the dipole moment, particular component along the along the diagonal direction? So this arrow will have how many components? Two components, one along this diagonal, another one along that side, isn't it? Similarly over here, one along diagonal, one perpendicular to it. Similarly, this is downwards, so this one along this side, and one. But I think this one will be not this side. This one will be towards this side, isn't it? Now the net dipole moment is downwards. This one along this side, and one along this side. Are you able to get me? So these are my directions of the dipole moment, isn't it? So now look over here. So if I just consider along, that means after taking component and all of them make angles 45 degree with the side, isn't it? So after taking component, each component is how much? P by root 2. Each component is how much? P by root 2. So look over here. Yeah, it will be P by root 2 or not? So then you try to find the dipole moment at the center. Think what will be the dipole moment? Sorry, what is the net electric field and potential? What I should write? Tell me. If you tell you today, then there is a party. This is a very awesome question. So look over here. See this. See this, Balak. Acha, due to these two, there will be two electric fields along this line or not? See, first from these, the electric field will be, let us type, first electric field will be E due to this, isn't it? You see that? Try to see. Whenever you get a dipole, like look over here, whenever you get a dipole, and if you take the resolution, then you have basically how many components? Two components, one along the perpendicular, one along the parallel, isn't it? Are you able to get me? And for both of them, the electric field will exist, isn't it? So you have to think in that sense only. Is that clear or not? So apply that. If I just consider due to this, the electric field will be this, and due to this, for the like for the equatorial, the electric field will be E, isn't it? But for the axial, the electric field will be twice of E, isn't it? Because since the components are same. अरे कुछ तो बोलो हाँ ना. Look over here, it is P by root 2 along this side and P by root 2 along that side also. So electric field R means since the dipole moments are same. So what I can write? See this. E cos alpha will be simple. What it will be? Twice K P cos 45 divided by R cube or not. So what is this? Twice Kp by R cube into root. Similarly, E sin alpha is what? Twice Kp, sorry, just Kp by R cube, Kp sin 45 by R cube, isn't it? So Kp by R cube into root 2. But when you take the square of them, they becomes what? E, isn't it? And that will come as Kp by R cube into root 2, isn't it? Are you able to get me? So E cos alpha will be what? Twice of Kp by R cube into root 2 means twice of E, and this is how much? Are you able to get me or not? Is that clear? So therefore, one component is E plus twice E due to this both of them. For them also, it will be what? E plus twice E. Are you able to get me? Is that clear? Now look over here. Due to this, what will be there? E plus. Now you see that the for these the electric field is E, isn't it? For sorry, wait. Let us write in terms of axial and equatorial. Okay. So for this the electric field for this axial electric field it is twice E, isn't it? And due to this axial also it is twice. Are you able to get me or not? Due to this perpendicular means due to this perpendicular and due to this perpendicular, where will be the direction of electric field? It will be along this side, isn't it? Opposite of dipole moment vector. Yes. Uh, 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 uh. 1 minute, 1 minute. No, wait. I think I'm doing it wrong. It can be done in a very easy fashion. Wait. No need to consider that many things. Wait. Sorry. Let me do it in normal fashion. No need to consider that many kind of calculations. It's very easy actually. Why to consider all those kind of points? Okay, let me draw once again. The dipole moments are like this way, isn't it? The resolution of them. Hey, it's very easy now. Okay, 1 minute. Okay, and this one, yeah, one along this side, one along this side. Acha, all components are 45. So one will be E and another one will twice E. That we know, isn't it? So look over it, simple. Acha, due to this, along this direction, the electric field will be how much? Due to this axial field, twice E. Due to this, twice E. Yes, are you able to get me? Now look over here. Due to this, the electric field. First, I'm solving these two components. Means this one and this one. So due to this one, the electric field will be along this side or not? Which is how much? E. Due to this, the electric field will be along same direction, which will be E. Are you able to get me? So E plus E. Is that clear? Yeah, I'll use the different color to represent it. Okay. So that is due to this one opposite E. Due to this one opposite E. Are you able to get me or not? Now look over here. Due to this one, and once again, for I'm solving now this diagonal. Okay, so for this, the electric field is twice E, isn't it? And for this also, the electric field is same twice E. So twice E plus twice E for both the axial regions. Are you able to get me or not? Now perpendicular one is left. So perpendicular one, this one for E, this one it will be added E. Are you able to get me? And for this perpendicular, it will be in this opposite direction or not, which is E. Are you able to get me? So net electric field, see, on this diagonal it is getting cancelled out. Twice E plus E, twice E plus E. So this got cancelled out. So net electric field at the center is how much? 4E minus twice E, which is equal to twice E. Are you able to get me or not? And then E will be how much? E is simple. It is, if I am considering E, E was Kp sine theta Now, if this is A, this is A. So what is this distance? This distance from one of the vertices. So I can just calculate it now. If this is A, this is A. So total diagonal is how much? ध्यान से देखो. This is root 2A or not? So then half of it will be A by root 2. So A by root 2 का whole cube. Are you able to get me? Sin theta, sin that theta is 45. So it is Kp by root 2 into A by root 2 का cube. Are you able to get me? Is that clear? So what I get? I get it. This is root 2 ka cube, 1 root 2 cancel, and 2 square is 2. So this is twice Kp by A cube. Are you able to get me or not? So net electric field at the center is twice E. So that means E at the center is simply how much? 4 Kp. Are you able to get me? Is that clear? Perfect. Sure. So now what we have to find the like potential, isn't it? So now look over here. See, for potential I can use direct formula of P vector dot R vector by R cube or not. Yes. So you can see that if I just consider, let's suppose if I have any dipole, here it is positive, for another it will be negative, for another it will be positive, for another it will be negative. So when you are finding net potential will be what? Net potential, look over here. The net potential only exists due to which component? Cos theta component. अरे कुछ तो बोलो हाँ. So net potential, so only due to the component along diagonals. Is that clear? So now you think, now for which it is obtuse, for which it is acute, and for that I'll get the net p vectors, isn't it? So look over here, let us see that. So v net is equal to how much? Okay, for this the angle is acute angle or not? Theta is acute, isn't it? So for this the potential will be simple Kp cos 45, which is root 2, isn't it? So Kp by root 2 divided by this distance is R by root 2, A by root 2, isn't it? So for this is for first one. Consider this as first, second, third, fourth. Now look over here. If this is my this dipole is like this way or not, and R vector is toward this side. So what is this angle? Acute or obtuse? For this dipole, the angle is once again acute. For this dipole, the angle is once again acute. So for three cases, I have an acute angle. So this component, yeah, it will be thrice minus 1 the acute or not, which is Kp by root 2 by A by root 2 का स्क्वायर था ना कि क्यूब था? के स्क्वायर था. If I take P cos theta, so square. Are you able to get me? So what you are going to get? Simple. You will get basically it will be something like 2 root 2 Kp by A square. Is that clear? That's an answer. Are you able to get me? So that's my net potential due to the square. Is that clear or not? Now look over here. So you got the idea that what you have to do whenever you get the dipole, resolve it. Okay. And for that one along the cos theta component, the electric field will be twice E, and one along the perpendicular direction of it, means along this direction, the opposite electric field will be E only. So I'll just represent it. You remember this trick always, because there can be sometimes they ask on this rectangle and something like that. That when I have this as my dipole moment, then I have two components. If this is theta, this is p cos theta, and this is p sine theta. And if theta is same, means if theta is 45 degree, then I have two electric fields, E cos alpha and E sine alpha. Is that clear or not? In the opposite direction. Are you able to get me? Okay. And that depends, if theta is same, then one will be E and another will be twice E. Is that clear? Okay. Now look over here. See, the point is, as dipole has plus and minus charge. Now think of one case. Let's suppose, okay, let's suppose this is plus q, and this is minus q. Okay. And the gap between them is once again how much? Twice L. Got it? Hmm. Yeah. Acha, what happens? Let's suppose if I just create one electric field like this way. Tell me, where is the direction of force on plus q? Where is the direct? In which direction the force is there on plus q? If this is my direction of electric field, the charge plus q will feel the force in the same direction of electric field or not? F is equal to qe. Minus will feel the force in which direction? So look over here, you can see that these charges can be, means these charges will start to rotate or not. Yes, basically these charges will rotate. If this kind of electric field is present, if I place a dipole in the electric field, what will happen? They will start to rotate. But the condition is I must put them perpendicular to the electric field, isn't it? What if I place this minus q and plus q as in the this direction, like in similar in this way? Then initially, if they are in this way, then this is filling the force towards this side, this is filling the force towards this side, so no charge will go anywhere. Is that clear or not? They will not rotate. Are you able to get me? So minimum condition to rotate is I need to put them along the direction at some angle theta with respect to the direction of electric field. Are you able to get me? Is that clear? So now look over here, what is actually happening? You can see that, let's suppose if I consider this angle is theta. Now, if forces are able to rotate, that means the body is experiencing some kind of a torque, isn't it? And that's our topic for the point right now. That what if happens if I have electric dipole in the uniform electric field. First, we will consider uniform electric field. Is that clear? So if it is a uniform electric field, you can see that, see, this force will have two components. If this is twice L, then this is R vector, isn't it? I can create a triangle like this way or not? Yes. Are you able to get me? If this is L and this is L and this angle is theta, so this will be how much? L sine theta. And this angle will be also theta because this is 90. So this is how much? This is also going to be how much? Perpendicular will be L sine theta. Are you able to get me or not? So look over here. Basically, we can write that torque is equal to how much? We know that torque is given by formula. Torque is a vector quantity, isn't it? Sorry, I have. So look over here. First thing, to define torque, we need that we see that the net force on the particle is how much? Zero. So that means the body will not translate. The body will not go anywhere. Is that clear or not? The body will only rotate. So basically, to rotate, I need a torque. So torque on the particle is how much? Simple torque is given by, torque is represented as tau, and it's a vector quantity, and it is given as r cross f or not. But this can be written as r perpendicular f, because rf sin theta is there and r sin theta is the perpendicular component, isn't it? So definitely look over here. For f, this is what? F L sin theta, isn't it? And then look over there. If I just consider the rotation, this will try to rotate clockwise, and this one will also try to rotate clockwise or not. So that means the torque due to both the forces are positive. FL sin theta. So definitely tau is equal to how much? Twice FL sin theta. But what is F? QE, isn't it? So twice Q into electric field E L sin theta. But what is twice Q into L? That is my dipole moment, isn't it? So therefore, we write it as torque vector is equal to PE sin theta. But look over here, which vector is rotating which vector? Dipole moment means electric field is rotating my dipole moment, isn't it? So in terms of cross product, it is written as the vector which is rotating cross the vector which is rotated. Are you able to get me? So it should not be written as E cross P. E cross P is something else. That means dipole moment is rotating electric field, but here it is opposite. So this is, that is why it is written as P. That means that what is actually happening is dipole moment is always trying to become parallel with the electric field. Is that clear or not? Are you able to get me? No, look over it. If you have any kinds of doubt till now, please ask. Otherwise, I'll move ahead. Mhm. Okay, so now look over here. The point is, see, as the body is experiencing force, body is rotating also. It is doing some angular displacement, and the body is at rest or not. So when a body experiences force, see, when the net force on this two body system is how much? Zero. And the body is not going anywhere, but it is rotating. So how come it is getting that rotational energy? It should come from somewhere, isn't it? So basically, it comes from this particular condition that since it is rotating, that means it is getting some kind of rotational kinetic energy that is only provided by the energy which is stored over there in that particular system, dipole system, due to the electric field or not. And that energy we call it as potential energy of the dipole. So basically, to rotate something should provide some energy, isn't it? So this is why it is necessary to find potential energy of dipole in uniform E field. Is that clear? Are you able to get me? So look over here. Let's suppose this is, if I write plus q and minus q, so this is my dipole moment vector, isn't it? And this is my electric field vector. and initially they are making some angle theta, and the torque is opposite of it, isn't it? So look over here, we know that electric field is a conservative force. So basically, whatever is the change in potential energy, which is represented as U, that should be equal to the net work done by the torque, isn't it or not? Now work done by torque is given by what formula? Since torque is creating a displacement of d theta, so this is why it should be given as integral. Since theta is opposite of torque, so torque vector dot d theta vector. Are you able to get me? So now look over here. What is my delta change in potential energy? Change in like we know that 1 minute. Let us write minus. Okay. So you know that for conservative field, work done is equal to change in negative of change in potential energy or not. So basically, potential energy will be what? Negative of work done. So that should be equal to negative of tau dot d theta. Are you able to get me? Now look over here. This torque, if I see that torque is trying to rotate the dipole moment clockwise, while the theta is taken anti-clockwise or not. So that means this work should be basically positive because tau dot d theta is cos 180 degrees. So it should be tau simple dot d theta. Are you able to get me? So it should be integral p sine theta d theta. Is that clear? And let's suppose if it is rotated from theta 1 to theta 2, then change in potential energy, or you can say potential energy final minus potential energy initial is equal to, since sine theta is minus cos theta, so it is p minus p cos theta 2 minus cos theta 1. Is that clear? Are you able to get me? So now look over here. This is the formula for, if I rotate the particular dipole, then how it is getting the energy, rotational energy? It is by this stored potential energy. Is that clear or not? Nothing. See, we usually see we can't leave it at 0 degrees because at 0 degree it can't rotate, isn't it? So maximally, initially I can start it from theta is equal to 90 degree or not. So when theta 1 is equal to 90 degree, isn't it? At that time it was not rotating. So at that time potential energy initial will be how much? Zero also, isn't it? So potential energy finally becomes how much? Minus of p cos theta if it is rotated by angle theta. Is that clear? But what is this minus of p cos theta? That is nothing but minus of p vector dot p vector. So net potential energy stored in the electric field of the dipole is minus of dipole moment vector dot electric field. Are you able to get me? Is that clear? So look over here, you can say that now you got to know that minimum potential energy is at theta is equal to 0 degree, isn't it? And maximum is at theta is equal to 180 degree. Is that clear? So minimum is minus of p, theta is maximum, so that is plus p. Are you able to get me? Plus p means here is my positive charge, here it is negative charge. For plus charge, it will fill the electric field force towards this side. For minus is towards this side. So this is the most stable configuration or not? So that is why it has maximum potential. Are you able to get me? So now that means we have the particular dipoles also in terms of stability and instability, isn't it? So let us see. Okay. So this is my electric field directions. And let's suppose I started placing dipole, one along the same direction, okay, another opposite direction, another one perpendicular to it. Are you able to get me? Is that clear? So this is dipole moment vector, and this is also dipole moment vector. So here theta is 90, theta is 180, and here theta, oh sorry, here theta is 0, and here theta is 90. Are you able to get me? Now if theta is 0, you know that for theta is equal to 0, if I find torque will be 0. Torque is how much? 0. Here also torque is 0. Here torque is P, isn't it? Are you able to get me? Then talk about the stability of all of these configuration. Which one is stable, which one is not stable? Acha, you look over here. We studied in work energy power F is equal to minus du by dr or not? So the body is in equilibrium when the force is 0. So these bodies all are in equilibrium or not? Not this one. This one is in equilibrium. This one is also equilibrium. Now look over here. If potential energy is maximum, then the force will be minimum or not? And if potential energy is minimum, force will be maximum. And so look over here. When we used to write F is equal to minus, listen. When we used to write F is equal to minus du by dr. So when this potential energy used to be, when potential energy used to be maximum, then it used to be unstable equilibrium because the graph was like this way, isn't it? And when the potential energy used to be minimum, then the particular graph was of a stable equilibrium or not. So we categorized equilibrium in our three different ways. One is stable, unstable, and neutral. So here, if I look into this, F net is 0. So that means there is an equilibrium. But potential energy is what? Minus P, which is minimum. Here, potential energy is P, which is, and here potential energy is 0, which is neutral. Are you able to get me? So here, it is a which kind of case? When minimum potential energy is there, it is a stable equilibrium. When this is unstable equilibrium. Are you able to get me? And that's not an equilibrium because torque is not 0. Are you able to get me or not? So that means that what is the condition? Which is the most appropriate condition for the dipole? Dipole will always have, means the dipole will always try to go into that equilibrium which is an stable equilibrium, isn't it? Which is an stable equilibrium. So that means our dipole, earlier I told you that dipole is always trying to become parallel with the electric field. That means the parallel means the dipole will always try to come into this first configuration, not into this second configuration. Is that clear or not? So this means that dipole moment is always trying to become parallel with electric field. Is that clear? Mhm. Okay, so let us do some questions based on this. Okay, so theoretically, all your dipole is not over because there are some cases still are left. Okay, let us just complete that, then I'll do some questions. Is that clear? So now, see, right now we consider the dipole in an uniform electric field, isn't it? But who said that only uniform electric field can exist? There can be non-uniform electric fields also. So give the heading dipole moment, dipole in a non-uniform electric field. Is that clear? So let's suppose if I consider a non-uniform electric field, that means electric field lines will not be parallel, isn't it? Is that clear? So this is my electric field and it is a non-uniform. Are you able to get me? And I placed some dipole over here. Let me erase this second line. I placed some dipole. Okay. Is that clear or not? This is minus Q and this is plus Q, isn't it? Now tell me what will happen. See, plus Q plus Q. Since this electric field is bending towards this side, will feel the force along this side or not? Minus Q, since it will feel the force in opposite direction of electric field, isn't it? So it might be like this way. So this is my force F1 and this is my force F2. Are you able to get me or not? Now the question arises, see, here my electric field is converging and here my electric field is diverging. So that means the magnitude of force 1 on my dipole will be less than magnitude of force on the particular second charge minus q, isn't it? Because here the electric field is converging. That's more nearer, isn't it? Are you able to get me? Okay. So now look over here. Now see, although whatever is there, nothing actually changes because these forces ultimately I need to consider with respect to r perpendicular, isn't it? So torque is still same, which is P sine theta. Is that clear or not? And dipole potential energy of dipole is still same, which we consider it to be minus P cos theta, which is minus P vector dot E vector. Are you able to get me or not? But here the net force is not zero. F net is not equal to 0. Are you able to get me or not? So then we know that since electric field is variable, then force on dipole can be found out. So dipole experiences a force which must be calculated since E is variable and potential energy formula I know. So I can write it directly minus of du vector by dr, sorry, du by dr or not. Yes. So then our force vector we can calculate easily on my non-uniform, if a dipole is placed in non-uniform electric field, which is minus du by dx I cap plus du by dy j cap plus du by dz k cap. Is that clear or not? Are you able to get me? And if now the exception comes, and if the electric field is in the same direction for both charges, for both plus q and minus q of dipole, then force is simply, since u can be written as p dot e or not, and since they are same, so it is p. Are you able to get me? So it is minus, just simple, p dipole moment will come outside, d by dr. Is that clear or not? Are you able to get me? So that's your dipole in an non-uniform electric field. Is that clear? So we have two cases: uniform electric field and non-uniform electric field. In non-uniform electric field, we mainly focus on force on the dipole because torque is still same, which is p sine theta. Potential energy is still same, which is p cos theta. But the force is non-zero, and that's why we calculate the force equation for the potential and electric field equation. Is that clear? Okay. Write it and then we'll move ahead. Okay. So we completed all our dipole. Is that clear? This was the main part of the dipole. Now let us do some questions based on this. Okay. Write one question. बोल रहा है कि find E and B at point B if a dipole P vector is placed at point A. ठीक है? And P vector is given. It is 4i cap minus 3j cap into 10 to the power of minus 9 centimeter. Okay. And point A is given. A coordinate is 3 comma 5 comma 6, and B coordinate is also given 5 comma 3 comma 7. बताओ. 7. 5 comma 3 comma 7 B का. Tell me what will be the answer. What will be the answer? Acha, I'll tell you one thing to handle this question. We want electric field and potential in such a random vector R, isn't it? So random vector R, create it first. What is that? 5 minus 3, 2 I cap plus 3 minus 5. So that is minus 2 j cap plus k cap, isn't it? Now, when you are finding, see, electric field at any such random R vector and all, it is given as, what is that relation? It is given as, we'll have to follow this rule, isn't it? E is something kp cos theta, well, like kp vector by r cube 1 plus 3 cos square theta and all, isn't it? But you do not know cos theta. Do you know cos theta? There is a rule to find cos theta. See, like in a most easiest way, what is cos theta? Look over there. If I see p vector we know, r vector we know. If we know p vector and r vector, then cos theta is easier to find, isn't it? Cos theta is what? Simple p vector dot r vector divided by what? Magnitude of p and r, isn't it? I can apply the dot product or not? So look over here, simply do that. You know your p vector, you know your r vector. So cos theta is what? P vector, that is 4 I cap minus 3 j cap dot r vector 2 I cap minus 2 j cap plus k cap into 10 to the power of minus 9 divided by magnitude of it. Okay, I don't know. So what I will get? This is 5 into 10 to the power of minus 9 and 2 2s are 4, 4 4s are 8, 1 9. So this is 3. So this and this got cancelled. 4 2s are 6 minus 3 2s are 6. So cos theta is basically how much? Minus minus plus. So it is 14 by 15, isn't it? It's all simple. So electric field vector is what? E is equal to twice Kp, like Kp vector by R cube into 1 plus 3 cos square theta, isn't it? So apply this formula, you will get the answer. And potential is what? Kp cos theta by R square. Apply both of the formulas, you'll get the answers over there. Is that clear or not? So can you just apply and get the answer? It's your task, okay? To solve this and get the answer. Okay, now? Okay, now look over here. So I'll give one more question. बोल रहा है कि there is a dipole of dipole moment P, okay, and moment of inertia I. Got it? And it is stable. It is in stable equilibrium in external electric field E. Is that clear? The question is find the time period of oscillation. Find the time period of oscillation if dipole is slightly rotated by angle theta and released. So this is your question of your homework. You try it and then we'll talk about this in a much more greater sense. Are you able to get me? So we'll have one more class of a little bit of dipole and then we'll start conductors and capacitors. Is that clear? And then we can move to our next chapter which we call it as current electricity.